All right, guys, I'm back at my next video here for Module 6, the assessment problems, and this is number 3. And this is your number 3, just like the other ones. And I'm going to read it and then make some comments that I think will help you. So it says basketball players who score a lot of points also tend to be strong in other areas of the game, such as number of rebounds, number of blocks, number of steals, and number of assists. Below are scatter plots and linear models for professional NBA, National Basketball Association players last season. All right, so then on this first one here, you kind of see that it says the equation that represents this scatter plot is given as y equal 21.54 plus 3.833x. Now, that's a slope-intercept form of an equation, but usually we would see it like this, so I just kind of retyped this over. This is how it's given on the test. I did this for you because I thought it would help you more. So when you're looking at these equations, right, you want to look and see, what the x variable is and what the y variable is. So here on this scatter plot, right, this is your rebound one. The x-axis is number of rebounds. Y-axis is your points scored. So this is kind of the equation that goes with that. So if you picked a number along the x-axis, let's just say like 200, you could put that number 200 in for x, and then you could evaluate this using order of operations, right? You'd multiply those, add that, and that would give you an idea of the total amount of points that that player scored for the season. So that's kind of how you interpret that scatter plot. All right, now the next one, right, and at the top you see the equation. It says y equal 294.9 plus 22.45x, or I just rewrote this with the x variable first because that's usually how we see it, right, in slope-intercept form. And it's the same idea, right? You're going to go to the x-axis and see what the x-axis is representing. It's number of blocks, and the y-axis again is points scored. So look, if you would go and pick like a number of blocks that the player had in that season, let's just say you pick 30 and you sub 30 into the equation for x, then you can multiply and add those together to find the number of points scored. And it's the same idea for the next graph, right? This equation here is in slope-intercept form. The x-axis is steals, y-axis is points. So if you pick the number of steals in a season and sub that number in for x and do your order of operations, multiply and add, you could predict how many points the player would score, right? And then the last one is, again, it's in that slope-intercept form. The x-axis is assist and your y-axis is points, and you could pick the number of assists, sub that in, and you could predict kind of the points scored. So that's what those different dots are representing, okay? So question A says the line that models the association between points scored and number of rebounds is, and that's from that first one that I showed you, right? And here they have it written kind of backwards, right? I rewrote this and I made it look like this, right? I put the y equal the 3.833x plus the 21.54, right? So it says where y represents the number of points scored and x represents the number of rebounds. So give an interpretation in context of the slope of this line. So I kind of told you what to do on that, The x-axis is representing rebounds, y-axis is representing points. So just based on these numbers, tell me kind of what that means. And then when you go on to question B, it says the equations on the previous page all show the number of points scored, y, as a function of the other variable. And I kind of went over that for you, right? So it says an increase in which of the variables, either an increase in rebounds, an increase in blocks, an increase in steals, or an increase in assists, tends to have the largest impact on the predicted points scored by an NBA player. All right, so that's kind of a weird question. So what you would want to do is when you go back and you look at these different, scatter plots that you have, right? You have one for rebounds, you have one for blocks, you have one for assists, and you have one for steals, okay? And if you look at the line of fit, now remember the line of fit on each, it's this line here that's been drawn. Remember what we said about lines of fit. when you draw them, it should intersect at least 2 of the points. So what you could do, right, to answer question B is go to each line of fit, pick 2 points that are on there, and see if you can kind of approximate the x and the y coordinates for those 2 points, and then you could sub those into the slope formula, right? And the slope formula again is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And once you did that for each scatter plot and each line of fit, and you got a slope, you can compare the numbers on the slopes, right? And then whichever one you kind of, came up with as having the largest number, right? The largest slope, you could then tell me the number and whether that number was representing rebounds, blocks, steals, or assists, right? Because it says an increase in which, right? So the biggest increase would then tell you which had the largest impact on points, right? Because they're all impacting points scored, right? It's rebounds related to points scored, it's assists related to points scored, it's steals related to points scored, and it's blocks related to points scored. So find the slope, and that should be able to help you answer that question. Now C, this last question, it says, which of the 4 linear models shown in the scatter plots on the previous page has the worst fit to the data? Explain how you know using the data. Now remember what you learned about scatter plots and lines of fit, right? You got 3 choices on what you think is going on with the correlation, right? It's either going to be a positive correlation, a negative correlation, or no correlation. And you're looking at it left to right. So you're going to look at all 4 of them, and you're going to kind of see where the scatter point plots, the points that are plotted are at regarding or in relation to the line of fit. A really good scatter plot with a really good line of fit will have about the same amount of points above it as there are below it, all right? And you're also looking to see, where you have a nice steady increase or it's rising from left to right, okay? So compare all 4 of them, and if you think there's one that kind of looks like there's not as strong of a correlation or a connection, a positive, they all have a positive correlation, right? There's some kind of connection between assist and points scored, between block shots and points scored, between steals and points scored, between rebounds and points scored. But which one looks like maybe the points are more scattered all around and it doesn't have the strongest positive correlation looking at left to right? And that's what you should choose to answer that last question down here on C, okay? All right, hope that helps, guys. Send me some questions if you still need further assistance. Remember, these are due Friday, May 22nd by midnight. Thanks. Have a good one.